Music theory is the study of the practices and possibilities of music. It generally derives from observation of, and involves hypothetical speculation about how musicians and composers make music. The term also describes the academic study and analysis of fundamental elements of music such as pitch, rhythm, harmony, and form, and refers to descriptions, concepts, or beliefs related to music. Because of the ever-expanding conception of what constitutes music, a more inclusive definition could be that music theory is the consideration of any sonic phenomena, including silence, as it relates to music. The present article is about music theory properly speaking, i.e., about theories, speculations and hypotheses made about the various aspects or music. It describes the elements of music only insofar as they give way to such theories. Other informations about these elements will be found in other articles such as Aspect of Music. The specific parameters of music described there. Textbooks, especially in the United States of America, often also include under the term theory elements of musical acoustics, considerations of musical notation, techniques of composition, etc., which will not be dealt with as such here, but only as they were the subject of theories and hypotheses. Music theory is a subfield of musicology, which is itself a subfield within the overarching field of the arts and humanities. Etymologically, music theory is an act of contemplation of music, from the Greek theta epsilon omega rho iota alpha, a looking at, viewing, contemplation, speculation, theory. Also a sight, a spectacle. As such, it is often concerned with abstract musical aspects such as tuning and tonal systems, scales, consonance and dissonance, and rhythmic relationships, but there is also a body of theory concerning such practical aspects as the creation or the performance of music, orchestration, ornamentation, improvisation, and electronic sound production. A person who researches, teaches, or writes articles about music theory is a music theorist. University study, typically to the MA or PhD level, is required to teach as a tenure-track music theorist in an American or Canadian university. Methods of analysis include mathematics, graphic analysis, and, especially, analysis enabled by Western music notation. Comparative, descriptive, statistical, and other methods are also used. The development, preservation, and transmission of music theory may be found in oral and practical music-making traditions, musical instruments, and other artifacts. For example, ancient instruments from Mesopotamia, China, and prehistoric sites around the world reveal details about the music they produced and, potentially, something of the musical theory that might have been used by their makers. In ancient and living cultures around the world, the deep and long roots of music theory are clearly visible in instruments, oral traditions, and current music making. Many cultures, at least as far back as ancient Mesopotamia and ancient China, have also considered music theory in more formal ways such as written treatises and music notation. History. Prehistory preserved prehistoric instruments, artifacts, and later depictions of performance in artworks give insight into early music making and as such, might implicitly reveal something of the prehistoric theory of music. See for instance Paleolithic flutes, Gurdi, Anasazi flute. Antiquity Mesopotamia. See also Music of Mesopotamia. Sumerian and Akkadian tablets do include musical information of a theoretical nature, mainly lists of intervals and tunings. 3 tablets in particular, the first one known as the Philadelphia Tablet, the second one preserved in the British Museum, and the third one in the Berlin Museum, name intervals from a pentatonic or possibly a heptatonic scale. Another tablet from Ur similarly names the intervals for tuning a harp of 7 strings, probably by a cycle of fifths. These texts are concerned mainly with terminology and with mathematical descriptions. China. See also Music of China, Chinese musicology. Much about Chinese music history and theory remains unclear. The earliest texts about Chinese music theory are inscribed on the stone and bronze bells excavated in 1978 from the tomb of Marquis Yi of the Zheng state. They include more than 2,800 words describing theories and practices of music pitches of the time. The bells produce two intertwined pentatonic scales 3 tones apart, with additional pitches completing the chromatic scale. Chinese theory starts from numbers, the main musical numbers being 12, 5 and 8. 12 refers to the number of pitches on which the scales can be constructed. The Lushi Chunqiu from about 239 BCE recalls the legend of Ling Lun. On order of the Yellow Emperor, Ling Lun collected 12 bamboo lengths with thick and even nodes. Blowing on one of these like a pipe, he found its sound agreeable and named it Wangzong, the yellow bell. He then heard phoenixes singing. The male and female phoenix each sang 6 tones. Ling Lun cut his bamboo pipes to match the pitches of the phoenixes, producing 12 pitch pipes in 2 sets, 6 from the male phoenix and 6 from the female. These were called the lulu or later the xielu. The lulu formed the ritual scale to which many instruments were tuned. The name of the lowest sound, Wangzong, also implied musical correctness. Its pitch formed a pitch standard, setting the bass pitch of zithers, flutes and singers of imperial court orchestras. Straight-walled pitch pipes without finger holes were made of cast metal, their lengths specified by court regulations. The resulting chromatic scale provided 12 fundamental notes for the construction of the musical scales themselves. The lula also has a cosmological value. Its notes describe the energetic frequency of the 12 months of the year, the daily rhythm of the 12 bi-hours of the Chinese clock, the 12 main acupuncture meridians, etc. The 2 sets of tones dividing the 12-tone scale were generated by the method of subtracting and adding thirds, or sanfen sunyi, which involved alternately rising a fifth and descending a fourth through the subtraction or addition of a third of the length of the preceding pitch pipe. The resulting pitches produced by adding a third were referred to by Sima Qian in the records of the Grand Historian as pitches of superior generation, that is, the pitches of Ling Lun's male phoenix. The pitches produced by subtracting a third were referred to as pitches of inferior generation, that is, the pitches of Ling Lun's female phoenix. Apart from technical and structural aspects, ancient Chinese music theory also discusses topics such as the nature and functions of music. The Yuji, for example, manifests Confucian moral theories of understanding music in its social context, studied and implemented by Confucian scholar officials. These theories helped form a musical Confucianism that overshadowed but did not erase rival approaches. These include the assertion of Mozi that music wasted human and material resources, and Laozi's claim that the greatest music had no sounds. Even the music of the Qin zither, the genre closely affiliated with Confucian scholar officials, includes many works with Taoist references, such as Tianfeng Wanpei, India. The Samaveda and Yajurveda are among the earliest testimonies of Indian music, but they contain no theory properly speaking. The Natu Shastra, written between 200 BCE to 200 CE, discusses intervals, scales, consonances and dissonances, classes of melodic structure, melodic types, instruments, etc. Greece. See also Musical system of ancient Greece, list of music theorists, #Antiquity. Early preserved Greek writings on music theory include 2 types of works: technical manuals describing the Greek musical system, including notation, scales, consonants and dissonance, rhythm, and types of musical compositions; treatises on the way in which music reveals universal patterns of order leading to the highest levels of knowledge and understanding. Several names of theorists are known before these works, including Pythagoras, Philolaus, Archytas, and others. Works of the first type include anonymous division of the canon, kappa alpha tau omicron mu eta kappa alpha nu omicron sigma, 4th 3d century BCE. Theon of Smyrna, on mathematics useful for the understanding of Plato, tau omega v kappa alpha tau omicron mu alpha theta eta mu alpha tau iota kappa omicron nu k rho eta sigma iota mu omega nu epsilon iota sigma tau eta nu pi lambda alpha tau omega nu omicron sigma alpha nu alpha gamma nu omega sigma iota sigma 115140 c. Nicomachus Ageras R. Manual of Harmonics, alpha mu omicron nu iota kappa omicron nu epsilon gamma chi epsilon iota rho iota delta iota omicron nu 100150 c. Cleonides, Introduction to Harmonics, epsilon iota sigma alpha gamma omega gamma eta alpha mu omicron nu iota kappa eta, 2nd century CE. Gaudentius, Harmonic Introduction, alpha mu omicron nu iota kappa eta epsilon iota sigma alpha gamma omega gamma eta, 3d or 4th century CE. Bacchius Geron, Introduction to the Art of Music, epsilon iota sigma alpha gamma omega gamma eta tau epsilon chi nu eta sigma mu omicron epsilon sigma iota kappa eta sigma, 4th century CE or later. Alypius, Introduction to Music, epsilon iota sigma alpha gamma omega gamma eta mu omicron epsilon sigma iota kappa eta, 4th-5th century CE. More philosophical treatises of the second type include Aristoxenus, Harmonic Elements, alpha mu omicron nu iota kappa alpha sigma tau omicron iota chi epsilon iota alpha, 375–360 after 320 BCE. Aristoxenus, Rhythmic Elements, rho epsilon theta mu iota kappa alpha sigma tau omicron iota chi epsilon iota alpha. Claudius Ptolemy, Harmonics, alpha mu omicron nu iota kappa alpha, 127148 CE. Porphyrius, on Ptolemy's Harmonics, epsilon iota sigma tau alpha mu omicron nu iota kappa alpha pi tau omicron lambda epsilon mu alpha iota omicron nu epsilon pi omicron mu nu eta mu alpha, 232 3rd c. 305 CE. Middle Ages. See also List of music theorists. Middle Ages China. Some imported early Chinese instruments became important components of the entertainment music of the Sui and Tang courts. The bent-neck pipa, the bili, the kongho and the jiegu. They generated not only new repertories and performing practices but also new music theories. The pipa, for example, carried with it a theory of musical modes that subsequently led to the Sui and Tang theory of 84 musical modes. Arabic countries. Medieval Arabic music theorists include Abu Yusuf Yaqub al-Kandai, who uses the first 12 letters of the alphabet to describe the 12 frets on 5 strings of the oud, producing a chromatic scale of 25 degrees. Yahya ibn al-Munajjin, author of Risala fi al-Musiki, which describes a Pythagorean tuning of the oud and a system of 8 modes perhaps inspired by Ishaq al-Mawzili. Abu an-Nasr Muhammad al-Farabi, author of Kitab al-Musiqa al-Kabir. Ali ibn al-Husayn al-Isfahani, known as Abu al-Faraj al-Isfahani, author of Kitab al-Aghani. Abu Ali al-Husayn ibn Abdallah ibn Sina, known as Avicenna, whose contribution to music theory consists mainly in Chapter 12 of the section on mathematics of his Kitab al-Shifa. Al-Hasan ibn Ahmad ibn Ali al-Khatib, author of Kamal Adab al-Ghina, copied in 1225. Safi al-Din al-Umawi, author of the Kitabu al-Adwar and Ar-Rishala as-Sarafiyya. Mubarak Sah, commentator of Safi al-Din's Kitab al-Adwar. Inon. LXI. Anonymous commentary on Safi al-Din's Kitab al-Adwar. Europe, Modern China, Arabic countries, Europe, Renaissance. See also List of music theorists. Renaissance, Baroque. See also List of music theorists. 17th century, list of music theorists. 18th century, 1750 to 1900. As Western musical influence spread throughout the world in the 1800s, musicians adopted Western theory as an international standard, but other theoretical traditions in both textual and oral traditions remain in use. For example, the long and rich musical traditions unique to ancient and current cultures of Africa are primarily oral, but describe specific forms, genres, performance practices, tunings, and other aspects of music theory.